So when doing compound inequalities with the OR case, it's actually a little bit simpler than the AND. As far as actually doing the solving, we don't have to do it where it's squished in between. So if you already are looking ahead at the kinds, notice it's got all those OR statements in between, so we would just attack this as two separate inequalities. But as far as the graphing, this one we're not wanting to connect to the dots because we're not wanting both pieces at the same time, so where it's in between two things, we want everything but the two things in between, because we're wanting one piece or the other. We don't want what's in between them. So it's the complete opposite of the AND case. So I'm going to show you how to graph it. So this says write this statement as an inequality. So all real numbers x that are less than -2 or greater than 6. So there's not a fancy way to write this like there was for AND. You just literally write what this says as two separate inequalities. So it's x that's less than -2, so x less than -2. And then it says greater than 6. So we're going to have x is greater than 6. And we're wanting either of these. We don't want necessarily to have what's going on with both inequalities at the same time. We want one or the other. So if we're wanting to consider one or the other, we need to talk about all the possibilities. And so when we talk about those, we can show that on our graph. So x is less than -2. Since this does not have the bar underneath, it's just less than, we're going to put an open hole on -2. Okay? And then x is greater than 6. We're going to put an open hole on 6. So like I said, the AND case, we want to connect them because we want everything in between. But we want everything except for what's going on in between. So if we look at the symbols, less than -2, that means go to the left. So we're going to the left. Okay? And then greater than 6, well, that's going to the right. So if you see here, it's the complete polar opposite of what we would have done yesterday, because if we wanted between -2 and 6, we would have connected the dots in between. So notice we want everything away from -2 and everything away from 6, except for what's in between them. We care about everything but this piece. So that's what you're going to do on these OR statements. So they're going to look funny like this, where we've got one way going this way and one going the other. So, excuse me. So this is the first example. Number 2, the sum indicates plus. The sum of all real numbers m and 3 that is less than -4 and greater than 5. So we're going to write this as two separate statements. So sum of all real numbers m and 3 means we're doing m plus 3. So we're going to have m plus 3 on here twice. Okay, first case it says less than -4. So we're going to say less than -4. And second one says greater than 5. So since you got exposure to how to solve these yesterday and you already know how to solve one-step inequalities, we can go ahead and just get m by itself. So we're going to subtract over 3. And so -4 minus 3 is a -7. So m is less than -7, or subtract 3 over here. 5 minus 3 is 2. So m is less than -7, or m is greater than 2. So we can plot these again, and it should look very similar to the one above. So m is less than -7 means we're going to have an open hole on -7, and less means go to the left. So we're going this way. And then m is greater than 2, so again, open hole, and we're going to the right because we want greater than. So again, looks very similar. We want everything except for what's going on in between. That's what the OR case is. I either want this to be true or this one. I'm good with either one. Excuse me. The third one, the quotient of all real numbers s and 2. So quotient is division. The quotients of all real numbers s and 2 that is less than 0 or greater than 2. So we just write this in order. So we're going to have two statements with s over 2 in them. One of them is less than 0, and the other one is greater than 2. So now we just have one-step inequalities here to solve. So we just multiply by 2 on both sides. Multiply by 2. Multiply by 2. Okay, so 0 times 2 is 0, so s is just less than 0. Again, don't be afraid of 0. And 2 times 2 is 4, so s is greater than 4. So those are our two cases. S is less than 0 or s is greater than 4. So that's, again, we're having open holes both times. It's less than and a greater than. No, the or equal to part. So we're going to put an open hole on 0 and an open one on 4. And since this is less than 0, we're going to the left. And since this is greater than 4, we're going to the right. Excuse me. Alright, so that's how to write ORs and how to graph the OR compound inequalities. Let's do some of the more advanced solving. You'll still see some simple one-step inequalities just like that one. So like this first example is one. You just pretty much approach it as two separate inequalities at the same time. So I always like to rewrite it to make it easier for the algebra. So this, you just have one step to get b by itself. You just multiply by 2 because we're dividing by 2. And 2 times 2 is 4. So b is greater than 4. Or, over here, to get b by itself, we need to divide by -5 because they're being multiplied. And the opposite of multiplication is division. But remember, when we divide by a negative, we have to flip the sign. So greater than or equal to is now less than or equal to. Okay, left with b. And this is a positive 20, so 20 divided by -5 is a -4. So b is either greater than 4 or it's less than or equal to -4. So this is going to have an open hole on 4. And greater than means we're going to the right. This means we're going to have a closed hole on -4 because it's got that bar underneath. And since it's less than or equal to, we're going to the left. So that is number 1. Now, if you really want to test yourself, you can pause this video right now and attempt the second one. The second problem here is another one-stepper. So if you want to pause it now and attempt it on your own, please feel free to do so. I'm now going to go ahead and move over here to it. So I always like to rewrite it. N plus 4 is greater than -3, or n minus 7 is less than or equal to -17. So, to get n by itself here, we just got to subtract by 4. Nothing more than that. So, -3 minus 4 is a -7. And then for this one over here, we just need to add 7. N is less than or equal to, well, -17 plus 7 is -10. Now we just got to graph it. So greater than means open hole on -7. So -7 is going to be between -6 and -8. And we're wanting greater than that, so that's to the right. And then less than or equal to -10, well, that's going to be a closed hole on -10. We're wanting less than or equal to that, so that's to the left. So that is number 2. Again, if you would like to really test yourself, you could pause this now and try number 3. Number 3 is a 2-step on both of those inequalities. All right, number 3, again, I just like to rewrite them as 2 separate inequalities here. Okay, so on this one, to get x by itself first, it's best to add 10 to both sides to start, because we want to deal with what's closest to x at the very end. So negative 8x is left over here, less than. Negative 2 plus 10 is just take away 2 from 10, which is 8. Now, to get x completely by itself, we're going to divide by negative 8. But remember, dividing by a negative means we have to flip this sign. So less than is now greater than. We've got x by itself, which is good. And 8 divided by negative 8 is a negative 1. Now, if you want to pause and try the other equation or inequality here, go for it. Now that you've seen one of them, see if you can do the other one. If not, you can just hold on here. So even though we see this minus, our brain probably wants to go ahead and add over to the 2x, but we typically want the variable on the left-hand side like we do over here. So it's best to get rid of this 10 instead of deal with this 2x, because we like where x is right now. And even though we may think, okay, well, I want to add 10 over, well, this 10 is positive. So we're actually going to subtract it to get it to cancel. So we're left with negative 2x still on this side. And then 26 minus 10 is just 16. So now we want to get rid of this negative 2. And since it's being multiplied with that x, we're going to divide it over. And so we are dividing by a negative. So remember, we have to flip this. So greater than or equal to is now less than or equal to. We're left with x on this side, and 16 divided by negative 2 is a negative 8. So the negative 1 is going to have an open hole. So that's in between 0 and negative 2. And we're greater than that, so we're going to the right that much. And then here, negative 8 is going to have a closed hole. And we're less than or equal to that, so we're going to the left. Okay, so you might want to pause it if you don't have that all written, or if you want to attempt any of the others ahead of me. So number 4, just rewrite it like always. Okay, so first we want to get rid of this 7 because this 7 is directly attached to p, and we usually want to deal with that last. And since this is negative, I know our brains see the plus and want to subtract it, but since it's negative, we have to add it over to get it to cancel. So 63 plus 7 is 70. Now we're going to divide by 7 to get p completely alone. Well, 70 divided by 7 is 10. So p is less than or equal to 10. Okay, so that's the first inequality. Now on this guy, again, we want to deal with the 8 last because it's closest to p. We want to get rid of the strings that are attached to the ends here. So we're going to add 9 to both sides. Excuse me. So I've got 8p is less than or equal to. We're doing negative 17 plus 9. Well, that should be a negative 8. Now, to get p by itself, since these are being multiplied, we want to divide 8. Now, even though this is a negative 8 over here, we're dividing by a positive 8. So no sign flipping happens this time. So I've got p is less than or equal to negative 1. So if you notice on both of these, I've got less than or equal to 10 and less than or equal to negative 1. Okay, we want either one of those cases, but they're both less than. That's kind of crazy. Now, first let's deal with this 10. So it's going to have a closed hole. And we want less than that, so we're going to the left. Now think about this one. -1 is not on this number line that we see, but as you see, as it's counting down, -1 is going to be over here somewhere and show up along the number line. So if you thought about it, if you plotted that point, I'm sorry, my cat just got in the way. If you plotted that point, then we're going left, so we're just going to continue going that same direction to the left. So there are some rare occasions, it's very rare, with OR cases, where you can just have one line here, one solution on your graph. So I just wanted to make sure we saw one of those in the notes. But again, they're going the same direction, they overlap. 10's going to be bigger, so that's the one that we're going to show on the graph. I'm sorry, my cats are playing with things, so if you hear noises, I apologize. Alright, last one. We can do this. So, this one we've got. Excuse me, I'm so sorry. We've got variables on both sides. So 3p minus 1 is less than or equal to 7p plus 7. Or p minus 10 is greater than 2 plus 3p. Okay, so we want to get first all the p's together, and even though I know it seems a little confusing to move over the 7p, but it makes that better for us if p's on the left. It's a little bit easier to read for graphing. So 3p minus 7p is a -4p. Then minus 1 is less than or equal to 7. So now, to get this p by itself, we've got to deal with -1 first. So we're going to add over 1 to get it to cancel. 7 plus 1 is 8, so -4p is less than or equal to 8. Now we just got to divide over that -4. Now be careful. When you divide by a negative, you have to make sure you flip the sign. So less than or equal to is now greater than or equal to. So p is alone. And 8 divided by a -4 is a -2. So that's the first inequality solved through. Now I've got the other one. So same process. We're first going to move all the p's to the left-hand side. So we're going to move over this 3p. So 1p minus 3p is a -2p. Still minus 10 is greater than 2. So to get p started to be by itself, we want to deal with the 10 first. So we're left with -2p on this side is greater than, well, 2 plus 10 is 12. Now it's just one step to get p alone. Divide by -2. So again, multiplying or dividing by a negative makes us flip the sign. So greater than is now less than. Left with p. And 12 divided by a -2 is a -6. So these are our two inequalities, and I know this is a lot of work, so it may be good to box it to help us see. I usually box all my answers, so I apologize I have not been doing that on this page, but it's a good habit to have to kind of help with the crazy, all the amount of work that's shown. So my cats are really playing. I don't know if you guys can hear it on the video, but they're really playing in the hallway. So any of those loud noises is them usually. Alright, so now we just need to graph this. So greater than or equal to -2, that's a closed hole on -2. And greater than or equal to means we're going to the right. And then less than -6 is an open hole. And less means go to the left. And there you have it. There's our last answer here. So the sub's going to give you some practice to work on over these guys. And then you're going to also have a homework assignment. So if you have any questions, feel free to send them to me through the Remind. I'm more than happy to answer them.